Good afternoon, class, and welcome to Chapter 1, Chemistry in Our Lives. Chemistry is an important topic of study. It's the study of the composition, structure, properties, and reactions of matter. All of the substances in our world are made up of matter. Matter, at its most basic, is made up of elements. Elements then bond together to form compounds. A chemical is a substance that has the same composition and properties wherever it is found. We find chemicals all over the place in many everyday products, including laundry soap, toothpaste, lotions, and clothing. We're also going to talk about the scientific method. The scientific method is a set of principles that scientists use to guide them in their explorations and experiments. There are 4 steps to the scientific method. The first is an observation. The first step in solving any problem is to make an observation and ask questions about what you observed. The second step is a hypothesis. A hypothesis is a possible explanation for what you observed based on your current knowledge. It must be stated in such a way that it can be tested experimentally. Step 3 are the experiments. Experiments are performed which test the hypothesis. If the experiments disprove the hypothesis you initially created, then you return to step 2 and propose a new hypothesis based on your new knowledge at this point. It may be that many experiments must be run in order to obtain a valid hypothesis. Step 4, conclusions. When multiple experiments have given consistent results that agree with your hypothesis, then you can decide that you have a valid hypothesis. So a real-life example of this might be, suppose you come home late at night, reach over to turn on the light, and nothing happens. You might first hypothesize that the power is off. If you look around, you might see that the microwave clock is working fine. This disproves your hypothesis that the power is off. You might next hypothesize that the bulb is old and has blown out. If you think back to the last time you changed the bulb, this could be valid, but how do you test this? Change the light bulb. If the light bulb comes on, your hypothesis was valid. If the light bulb still does not come on, then you might hypothesize that you have a problem with the wiring to that fixture. This would require calling an electrician to diagnose the problem. Okay, so let's try an example. Example 1 says, identify each of the following as observation, hypothesis, experiment, or conclusion. Step 1, Joe notices that his face itches after breakfast on Monday. This would be an observation. He notices something. 2, Joe thinks he might be allergic to something he ate that morning. That is the hypothesis. Joe is hypothesizing that his face is itchy because he's had an allergic reaction. 3, every day for a week, Joe eats only one of the foods he had on Monday morning. This would be an experiment. For example, on Tuesday, bacon, Joe feels fine. On Wednesday, scrambled eggs, Joe doesn't itch. On Thursday, toast with strawberry jam, Joe is itchy for hours. On Friday, Joe eats his toast with butter and is fine. On Saturday, Joe puts strawberry jam on a bagel and is itchy all day. On Sunday, Joe eats a strawberry and is itchy all day. Those are all experiments. Joe is testing the hypothesis that he is allergic to one of the foods he had on Monday morning. Joe decided he must be allergic to strawberries. This is a conclusion, and it is a conclusion reached by the multiple experiments. For example, on Thursday, the toast with strawberry jam, Joe has narrowed it down to toast, butter, and the strawberry jam, and he's itchy. On Friday, Joe eliminates the jam, eats just his toast with butter. He doesn't itch, therefore he can eliminate those 2 foods. On Saturday, Joe puts strawberry jam on a bagel and is itchy all day. Now he has been itchy both on a day when he has had strawberry jam and toast and on a day when he has had strawberry jam on bagel. So now he has concluded that something in the strawberry jam is causing him to be allergic. On Sunday, Joe eats a strawberry and is itchy all day. So Joe finally decides that he is allergic to strawberries. Okay? Those are an observation, a hypothesis, an experiment, and finally a conclusion. All right, let's talk a little bit about learning chemistry and a decent study plan. First, you should read the textbook. I take all of my material from the textbook, which is why I require you to purchase it. So you should definitely read the textbook and the notes. You should also watch the lectures, which you're doing right now. When you come to a sample problem in the text or in the notes, you should attempt to work it out yourself. When finished, you should compare your answers to the answers provided in the text, or watch me work out the problem on the lecture and compare your answers in the end. Within each chapter of the textbook, there are several sections. At the beginning of each chapter is the looking ahead section, which lets you know what to expect. There are sample problems scattered throughout each chapter, and at the end of each chapter are a final set of questions and problems that allow you to practice what you have learned. There are also chapter reviews, concept maps, and key terms to help you along. For the midterm and final exam, all of my questions come from the textbook. I usually take them either from even-numbered homework problems, or I adapt to them from odd-number problems. I also take them from the reading of the text itself. Simply reading over the problems will not prepare you for my exams or quizzes. You will need to be an active participant in this process. This means pausing the lectures, pausing the videos, working through things on your own. When you come to an example problem in the chapter, cover up the solution. Try and work the problem on your own. Then uncover the solution and see if you've done it correctly. This is very important. Chemistry is a science of practice. If you do not practice, you will not do well in this course. So let's go over some steps to active learning. You should read each learning goal for an overview of the material. Again, those are at the beginning of the chapter. You should form a question from the title of the section you're going to read. If you're looking at a section, for example, learning chemistry, a study plan, your question might be, what is a study plan? Read the section looking for answers to your questions. So again, reading the section here, we found that an answer to our question is a study plan is something that will help you within this course. And it might be something like practicing the problems, reading the text, making notes. Finally, step 4, self-test by working sample problems and study checks, covering up your answer and doing the work yourself. Again, it is not enough to simply read through the worked out problems in the textbook or look at the answers for the worksheets that I have provided in D2L. You must do the work yourself in order to master the material. Number 5. Complete the questions and problems that follow the section and check your answers for the magenta odd-numbered problems. Answers to the odd number problems are in the back of the book. Finally, proceed to the next section and repeat the steps. Now let's talk about some important math skills for chemistry. Chemistry is a lot of math, okay? And there are some important skills. Number 1, identifying place values. For any number, you can identify the place values for each digit. For example, 3,725 grams. This number here. Oops. This number here. The 5 is in the ones place. The 2 is in the tens place. The 7 is in the hundreds place. And the 3 is in the thousands place. You can also go the other direction. For example, numbers that contain decimal points. 5.231. The 5 is in the ones place. The 2 is in the tenths place, the 3 is in the hundredths place, and the 1 is in the thousandths place. Please note the use of ths at the end. Ooh, that was tough to say. Ths, to indicate the decimal place. Using positive and negative numbers in calculations. This is also going to be important in chemistry. We have a lot of positive and negative numbers. When 2 positive or 2 negative numbers are multiplied or divided, the answer is always positive. So 2 positive numbers or 2 negative numbers multiplied by each other, the answer is always positive. If you multiply or divide a positive and negative number together, the answer is always negative. When adding 2 positives together, the answer is always positive. When adding 2 negative numbers together, the answer is always negative. When adding a positive and a negative number, the smaller number is subtracted from the larger number, and the result has the same sign as the larger number. To calculate a percentage, divide the parts by the total and multiply by 100. Solving equations. In chemistry, we often need to rearrange equations to solve for a particular variable. This process follows the following rules. If you eliminate a symbol or number by subtracting, you need to subtract that same symbol or number on the opposite side. If you eliminate a symbol or number by adding, you need to add that same number or symbol to the opposite side. Pretty much anything you do on one side of an equal sign, you must do to the other. If you cancel a symbol or number by multiplying or dividing, you need to multiply or divide the other side by that symbol or number. E. Interpreting graphs. There are 4 components to any graph: the title, the vertical axis, which is the y-axis, the horizontal axis, which is the x-axis, and the points on the graph. F. Writing numbers in scientific notation. Very large and very small numbers are often written in a kind of shorthand known as scientific notation. There are 2 parts to any number in scientific notation: the coefficient and a power of 10. The power of 10 tells you which direction to move the decimal point and by how many places. Now let's take a look at some examples. Example 2. A tablet of medication contains 432 milligrams of active ingredient. If the whole tablet weighs 625 milligrams, what is the percentage of the active ingredient? So to calculate a percentage, we divide the part by the total and multiply by 100. The part is the active ingredient. There are 432 milligrams. The whole is the whole tablet. The whole tablet is 625 milligrams. Again, take the part, divide by the whole, and multiply by 100. If we place this into our calculator, 432 divided by 625 times 100, we get 69.12%. 69.12%. Okay, example 3. It says solve the following equation for x. Solve the following equation for x. In order to solve for x, we must get x by itself. Right now, we have 3x minus 3 equals 21. In order to isolate the x, we must get rid of this minus 3 here. In order to get rid of it, let's add 3. Okay. But remember, we must add 3 to both sides. So now we have 3x minus 3 plus 3 goes away. And 21 plus 3 is 24. So we now have 3x equals 24. But we're not quite done yet. We haven't quite managed to isolate the x. In order to get rid of this second 3, we must divide. So let's divide by 3. 3 divided by 3 is 1. So those 3's cancel out. But again, if we divide by 3, we must also divide the right-hand side by 3. And we get x equals 8. Okay. Let's try another one. Example 4. Write the following numbers in scientific notation. 437,000. To write numbers in scientific notation, remember again we have 2 parts, the number and the power raised to 10. In order to do this, we must take the decimal point and place it immediately after the first number that is not 0. So in this case, the first number that is not 0 is a 4. So we have 4 decimal point. 3, 7. Then we have a 10 raised to a power. That power tells us how many places we moved the decimal point. So our original number was 437,000. Although there is not a decimal point in that number, it is implied that the decimal point is here. we have now moved that decimal point 1, 2, 3, 4, 5 places. We moved that decimal point 5 places. So our exponent is a 5. Okay. Now, because the number that we were placing into scientific notation was larger than 1, our exponent is positive. Okay, let's erase that and do another one. Okay, 0.00000000567. Again, we are going to place the decimal point immediately after the first number that is not 0. That's a 5. So we have 5.67 times 10 raised to a power. Now that power tells us how many decimal places we moved that decimal point. You can see the decimal point is immediately after this first 0. So we moved this decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 places. 9 places, so times 10 to the 9. However, because this number was less than 1, it is times 10 to the negative 9. Let's try another one, 732. Again, we're going to place the decimal point immediately after the first number that is not 0, times 10, and we are raising this to the power of the places that we moved it. Again, there is no decimal point written in this number, but it is implied that the decimal point is at the end, so we moved it 2 places. So this is 7.32 times 10 to the 2. Again, because this number is larger than 1, our exponent is positive. 0.0815. Okay. Again, we're going to write the decimal point immediately after the first number that is not 0. That's here. We moved that decimal point now 2 places. So this is going to be times 10 to the 2. Because this number is less than 1, our exponent is negative. So 8.15 times 10 to the negative 2. Okay, example 5 says, look at the following graph and determine the value of CH4 at 0 degrees, determine the volume of CH4 at 0 degrees Celsius. Okay, so let's find CH4. There are several lines on this graph. The red one represents CH4. We want to know the volume of this at 0 degrees Celsius. So if we look at our graph here, we see that on the temperature axis, 0 degrees Celsius is here. Okay, CH4, oops, my line is a little bit over. I'm going to erase this and redraw. There we go. CH4 at 0 degrees Celsius, the volume, we are going to trace CH4 at 0. We're going to trace this over. We see that that red dot is just a little bit below 150. So I would guess that this is approximately 140 milliliters at 0 degrees Celsius. Determine the temperature of CO2 at 150 milliliters. So let's erase our lines here. Now we're looking for carbon dioxide, CO2. CO2 is the dark blue line. We want to determine the temperature at 150 milliliters. So we're going to look at the volume here, 150 milliliters, and draw a line across. Okay, and we are going to draw that line until we hit CO2, which is right here. Okay. Then we're going to trace our line down. And our temperature is somewhere between 0 and negative 100. Looks like it's closer to the 0. It's not quite halfway, so it's definitely less than 50. So I would say this is somewhere around 20 degrees Celsius, if I had to guess. What is the volume of N2O at negative 200 degrees Celsius? So let's erase our lines on the graph. Okay. N2O is the yellow line, and we want to know what is the volume at negative 200 degrees Celsius. So again, we're going to look at negative 200, draw our line up here. We want to see where it intersects the yellow line, which is the N2O, and then we are going to trace that line where it intersects here across. And we see that it is somewhere between 50 and 100. It's not quite halfway between the 50 and the 100, so I would estimate that looks to be around 70 milliliters. Okay. These are just some very, very simple math concepts, math review. If you have any questions, please let me know. And this concludes Chapter 1. Thank you so much for listening.